Okay, welcome to the StressStrain Academy. So I am Sidhartha. So today in our last class we have discussed about mechanical properties of solids up to the Hooke's law. In this chapter we have discussed about what stress, strain, there are different Hooke's law, modulus of elasticity. What is modulus of elasticity? Three types of modulus of elasticity. What? Young's modulus of elasticity, bulk modulus of elasticity, shear modulus of elasticity. The three terms were associated with it. So in our last class we have discussed about the three modulus of elasticity. So another one important topic, this is called StressStrain curve. StressStrain curve. StressStrain curve. So what is StressStrain curve? Suppose if we draw one graph y o x-axis, so in x-axis we are given strain here and in y-axis stress. This is what? This is a graphical representation of what? How Hooke's law. Hooke's law means stress is directly proportional to strain. Suppose if a wire is there, if we apply a force in a wire, what will happen? It can be elongated, okay, small amount. This amount of change in length to the original length is called what? Strain. So after that, if we apply the StressStrain curve, we are getting this type of curve here. Okay, this type of curve we are getting. Suppose we are given here, this is point A, this is point B, this is point C, and this is point D. In our exam it may be asked that express or explain stress strain curve. So what is stress and strain curve? In this curve, so here A point, in the point A, stress is directly proportional to strain. This obeys what? Hooke's law. Hooke's law. This obeys Hooke's law because this is a straight line, directly proportional curve. So stress is directly proportional to strain in this section. Suppose after that we have discussed about what is perfectly elastic body and what is perfectly plastic body. So here in the point B, after the increasing of what force here, what will happen? The wires get to the B. In that B point we are getting is elastic limit. This is called elastic limit. After that, beyond this B point, we are not getting the elastic behavior of the wire. Meaning, what is the elastic behavior of the wire? Elastic behavior means what? Stress is directly proportional to strain. After this point, we are not getting the directly proportional curve. Then at point C, at point A, what? Hooke's law obeys. Hooke's law obeys. At point B, what? Elastic limit. Elastic limit, we are getting elastic limit. At point C, what is that? At point C, we are getting what? Plastic behavior. Here it is plastic behavior. Plastic behavior means suppose a wire we are getting here. So if we increasing the stress in the wire at point B, stress is directly proportional to strain. At point B, elastic limit we are getting. After increasing the stress, what will happen? At point C, plastic behavior. Plastic behavior means we have already discussed in our last class that what is plastic behavior? If we apply a deforming force in an object, its body can be deformed, and after removal of this deforming force, it cannot regain its original shape and size. So this is plastic behavior. Here this plastic behavior getting, and after the increasing the stress, this is called fracture point. This is called fracture point. So or break point. In that point, the wire can be breaked or other things. Okay. So this is called stress strain curve. In exam it may be asked that explain stress strain curve. So this is called stress and strain curve. At point A, Hooke's law of weight. At point B, elastic limit. And at point C is called what? Plasticity, plastic behavior getting. And at point D, fracture point or break point we are getting. So this is very, very important point or in exam point of view. So this is called stress strain curve. So after that, another some numerical problem and some different types of topics associated with and these mechanical properties of solids. So mechanical properties of solid. In mechanical properties of solid, okay, expression for elastic potential energy. So what is potential energy? We already know that what is expression for elastic potential energy. Suppose if we apply a force in a wire, okay, so what will happen? The string or wire gets elongated, okay. So how it is elongated? This is amount of energy will associated with it. So this what is the energy here? This energy is called elastic potential energy. So what is the expression for elastic potential energy? We are going to discuss here. So what is the expression for elastic potential energy? So suppose one diagram here. So this is a wire here. So wire is length L. So this mass of length will be increases. This length is called del L. This amount of force we applied here. So initially we are applying what? What is the initial force applied in the string? 0. Final force applied in the string is what? F. So average force is what is called average force. What is called average force? 0 plus F divided by 2. Because two terms are there. So how we can calculate the average between the two terms? Divided by 2. So 0 is the initial force applied in the string plus final force is the what? F, and 0 plus F divided by 2. So average force will be what? F by 2. So average force will be F by 2. So now if we increasing the length here after applied F force, then increasing the length means what? Some amount of work done will happen in this case. This amount of work done will happen in this case. So what is the amount of work done? Work done on the wire is, what is the work done on the wire? Work done is equal to W. We know that work done is equal to what? Force into displacement. What force? Average force. So average force into what? Displacement is equal to what? What is the displacement? What is this displacement? Displacement is nothing but increasing length. Increase in length. Increasing length. Average force is equal to what? We are already getting F by 2. Increasing length means what? Del L. This is del L. So work done is equal to what? F by 2 into del L. This amount of work done is what? If we apply a force in a wire. Okay. After that, our aim is to calculate to what? Potential energy. So what is the potential energy here? So this work done is also stored as a potential energy. So we can conclude as, so now potential energy is equal to what? We can represent U. Potential energy is equal to what? F by 2 into del L. So potential energy is equal to F by 2 into del L means what? So this is the elastic potential energy. Why we using this same formula as the work done? Because work done is stored as a potential energy. That's why potential energy is called F by 2 into del L. This is, suppose we can consider as equation number 1. So after that this equation we can modify it like that. Suppose we can represent 1 by 2 here, F by A here into del L by L here. So earlier equation is what? U into half 1 by 2 into F into del L, but we are using what? F by A into del L by L. what amount of terms we are using more here. So we are using maximum number A into L here. So what is F by 2? F by 2, 1 by 2. F by A means what? Stress into del L by L is called strain. A into L is equal to what? A into L is equal to what? Volume of the wire. Is it? Volume of the wire. So now the elastic potential energy we can represent U into half into stress into strain into volume of the wire. This is all about what? Another expression for what? Elastic potential energy. So now in exam, two questions are arise. First of all, express the elastic potential energy, and another question is express the elastic potential energy what? Per unit volume. Express the elastic potential energy per unit volume. Then how we can express this equation? So our another expression is what? Expression for elastic potential energy. U we can call a small u is called U by volume. So U by volume is, U means what? Elastic potential energy per unit volume. Elastic potential energy per unit volume is called small u, means U by V. So U is equal to what? Capital U is equal to what? Half into what? Stress into strain into what? Volume of the wire. Volume of the wire. Then divided by what? Volume. Volume and volume of the wire is cancel each other. Then elastic potential energy per unit volume is called half into stress into strain. So this is the another expression for what? Elastic potential energy per unit volume. So now elastic potential energy U is equal to what? Per unit volume is equal to half into stress into strain. This is the another expression for elastic potential energy per unit volume. Okay, then this equation we can written in different way like that. Said we know that U is equal to small u is equal to half into stress into strain. We know that stress is equal to, means Y is equal to what? Young's modulus is equal to what? Stress by strain, or stress is equal to what? Stress is equal to Y into strain. We know Y into strain. Y means what? Young's modulus of elasticity. So now in this case U is equal to what? Half into stress is equal to what? Stress. In case of stress we can written Y into strain, and after that strain, so half into Y into strain whole square. So this is the another expression for elastic potential energy per unit volume. So how we can, so elastic potential energy per unit volume, we are already expressed the elastic potential energy. Elastic potential energy per unit volume is what? U by V. So U by V, we know that after calculating what? U is equal to half into stress into strain. So this is another form of elastic potential energy per unit volume. So here Y is equal to stress by strain. Stress is equal to, we know that in terms of Young's modulus, Y is equal to strain. So if we apply here in stress, in terms of stress, if we apply Y into strain in place of here Y into strain, so what will happen? So this is the equation, half into Y into strain square. So this is the another expression. So new expression is equal to what? U is equal to half into Y into strain square. This is another expression for elastic potential energy per unit volume. So this is about the expression for elastic potential energy. Now I will repeat again. So what are the three formulas were arising here? The three formulas were expressed in this way. So first of all, what is elastic potential energy? Elastic potential energy is what? U, capital U is equal to what? Capital U is equal to half into what? F into del L. This is a one expression. Or U is equal to what? Half into what? Stress into strain into volume of the wire. Okay. Another one, small u is called as what? Elastic potential energy per unit volume. These two equations are same. These two expression is different. These two equations are called elastic potential energy, and this equation small u is called elastic potential energy per unit volume is expressed as what? Half into stress into strain, or u is equal to half into y into strains whole square. So this is the two terms associated with these are three equations. In exam it may be as a proof that half into y into strain square, similar same thing. This is the equation for what? Elastic potential energy per unit volume. Or in exam it may be asked, prove that half into stress into strain into volume of the wire. This is same thing about the elastic potential energy. This is all about expression for elastic potential energy. So next, another one new topic is called Poissons ratio. Poissons ratio. So what is Poissons ratio? Poissons ratio is a constant term. There is no unit in Poissons ratio. So what is Poissons ratio? Suppose the wire is of length L, diameter suppose D. Suppose if we apply force here, what will happen? That the lower portion will be elongated or increases the length. If the increases the length, diameter is decreasing. Is it? So what is the, this is a wire, suppose this is a wire of length L and this is diameter suppose D here. The wire length is diameter D. If we increasing, what happen? The diameter is equal to difference by what? Del D. Now we apply what? mg force here. So what will happen? Here two ratio will be here. This is the change in diameter and this is a change in length. Okay. So what is the Poissons ratio? Within the elastic limit, within the, what is Poissons ratio? Within the elastic limit, the ratio of lateral strain to the longitudinal strain is called Poissons ratio. So ratio of the what? Lateral strain to the longitudinal strain. So first of all, we don't know about lateral strain. So what is lateral strain? Change in dimension, change in diameter to the original diameter. Because here diameter, earlier diameter is a what? D, capital D, and change in diameter is a small d. This ratio, small d, del D by capital D is called what? Lateral strain. So now, first of all, lateral strain is equal to what? Del D by capital D. Here negative sign is given out. So what is negative? Because increasing force, decreasing the what? Diameter. So longitudinal strain is equal to what? Del L by L. So we already know that del L by L. So after that, what is Poissons ratio? Poissons ratio we can also the sigma. Sigma we know that what? Lateral strain to the longitudinal strain. Lateral strain divided by longitudinal strain. Lateral strain divided by longitudinal strain is what? Sigma is equal to what? Minus del D by D divided by del L by L. So sigma is equal to what? L minus L by D into del D by del L. So this is the expression for lateral strain. Okay? Okay, the Poissons ratio is what? Sigma is equal to lateral strain divided by longitudinal strain. This is very, very important. Okay, so in lateral strain, negative, because why it is negative sign here? Because if we increasing the force here, decreasing the diameter, that's why it is called as negative. So this is all about Poissons ratio. So Poissons ratio is what we can denote as sigma. The letter is sigma. So Poissons ratio means what? Lateral strain to the longitudinal strain. So sigma is equal to what? Lateral strain divided by longitudinal strain. So this is about Poissons ratio. So some numerical, important relationship between y means what? Young's modulus, kappa, bulk modulus, k, kappa, eta, modulus of rigidity, and sigma, lateral strain. These are very, very important for your numerical problem. So these are the what? First, y is equal to, Young's modulus is equal to 3 kappa 1 minus 2 sigma into another 2 for next second formula is what? Y is equal to 2 eta in bracket 1 plus sigma, and third one is sigma is equal to 3 kappa minus 2 eta divided by 6 kappa plus 2 eta, and another fourth one is what? 9 by Young's modulus y is equal to 3 by eta plus 1 by kappa. These are the some numerical based formula regarding the 3-4 terms. What? Young's modulus of elasticity y, bulk modulus of elasticity kappa, modulus of rigidity eta, and shear modulus or what? Poissons ratio is sigma. So these are the 3-4 numericals based formulas. What? These are very, very important. Note it down. So this is all about the mechanical properties of solid. Thank you.